Hello students, today I am going to start unit 4, that is cones. So first coming to the definition of cone. Definition. A cone is a surface a cone is a surface generated by a straight line which passes through a fixed point and satisfies one more condition, that is it intersects a given curve or touch a given surface. Touch a given surface. So this is the definition of cone. Okay, I will explain you through diagram. And a cone is of the form this is the cone. So this is the shape of the cone, and here we call this particular point as a vertex, and we call this straight line. So this straight line as generator. Generator is nothing but a line, and this shape is a circular shape. Circular base. Okay, so here the fixed point. So this is the cone equation, and in diagram of the cone, the shape of the cone. We are very well known that. So the shape of the cone is in this way. So coming to the definition, a cone is a surface generated by a straight line. So here the straight line is nothing but the generator. Okay. So which passes through a fixed point? Yes, it passes through the vertex. And satisfying one more condition, that it intersects a given surface. Here surface is nothing but the circular base. Okay. So we call this as a cone. Here the fixed point is called vertex. Fixed point is called vertex of the cone. Okay. It means the fixed point is nothing but this one. So this is the vertex. And the given curve or surface is called guiding curve or base curve. So we call the given curve or the surface as guiding curve or base curve of the cone. Okay. And finally, an individual straight line on the surface of a cone is called its generator. Its in the sense cone. So it represents the generator of the cone. So this is about cone. Okay. So we have to keep it in mind that the fixed point of the cone is called a vertex and the guiding curve or the surface. So it's called guiding curve or base curve. And the individual straight line of the cone is called its generator. Okay, right. So coming to the next point, note the line x by L is equal to y by m is equal to z by n is a generator of a cone represented by the homogeneous equation f of x comma y comma z is equal to 0 if and only if f of L comma m comma n is equal to 0. Okay. So this point states as suppose if we have given a generator of the cone, generator is nothing but line equation, and the denominator values L, M, N, x by L, y by M, and z by N. So element values, if those element values satisfies the given cone equation, it means we have to substitute L, M, M, N, L comma M comma N values in place of x comma y comma z in the given cone equation. Here cone equation is nothing but that is a homogeneous equation x y z. We call any homogeneous equation x y z as a cone equation from here onwards. Okay. So if you substitute those values in the given cone equation, and if it satisfies, when you substitute those values, then the equation gets satisfied. So then we say that the given line is a generator of the cone. Okay. So based on this, I am going to give you one problem. For example, example 1. So that x by 1 is equal to y by minus 1 is equal to z by minus 1 is a generator of the cone 5yz 8zx minus 3xy is equal to 0. Yes, this is the cone equation. Any homogeneous equation. A homogeneous is nothing but throughout the equation we are having the same degree. Yz, here the degree of yz is 2. Coming to zx also we are having 2. And xy also we are having 2. So throughout the equation, we are having a same degree, so that we call this as a homogeneous equation. Okay, of course, this is a cone equation. Now, what we have to say is, this is the generator of this cone equation. Okay, so in the above note, what we have to, what I have said is, just we have to substitute the values of L, 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 M, N in place of X, Y, Z in the cone equation. If it satisfies, then the given line equation is the generator of the cone. So for that, coming to the solution, first of all, we have to write the given code. So the given code is f of, since it is in x, y, z, so I am writing f of x, y, z is equal to 5y z, 8zx minus 3xy is equal to 0. So print this as equation number 1. And also we are having the line equation. So another given line is x by 1 is equal to y by minus 1 is equal to z by minus 1. So L comma M comma N is equal to 1 comma minus 1 comma minus 1. Okay. So now we have to substitute these values in the given code. That is, consider f of L comma M comma N. That is f of 1 comma minus 1 comma minus 1. This is equal to, this is we have to substitute x, y, z values as 1, minus 1 and minus 1. That I get 5 into minus 1 into minus 1 plus 8 into minus 1 into 1 minus 3 into 1 into minus 1. So this is 5 minus 8 plus 3, which is equal to 0. So therefore we get f of L comma M comma N is equal to 0. Okay, therefore whenever the line equation, the element value satisfies the given code equation, we say that the given line is the generator of the code. The given line is generator of the given code. So this is a short answer question. If you want to prove any line equation is the generator of the code equation, just we have to substitute the values of L comma M comma N in the code equation so that it satisfies. Whenever it satisfies, so then we say that the given line equation is the generator of the code equation. Okay. So one more example I am going to prove you. So coming to the example 2. Example. Show that the line x by L, y by M, z by N, where 2L square plus 3M square minus 5M square is equal to 0 is a generator of the code 2x square plus 3y square minus 5z square is equal to 0. So once again the same example. So we have to prove that the given line equation is a represents the given line equation is a generator of the code. Okay. So coming to the solution, first of all we have to write the given code equation. The given code is f of x comma y comma z is equal to 2x square plus 3y square minus 5x square is equal to 0. And given line is x by l is equal to y by l is equal to z by l. So now we have to prove that the values of L, M, N satisfies the given code equation. So that I'm considering f of L comma M comma N. This is equal to, we get 2L square plus 3M square minus 5L square. So but here elements are not constants. They're simply elements. So 2M square plus 3M square minus 5M square is equal to 0. I am writing this is equal to 0 because we have given that 2L square plus 3M square minus 5M square is equal to 0. So without this equation, we cannot write this is equal to 0. So since in the given problem, it was also given that 2L square plus 3M square minus 5M square is equal to 0. So when I substitute the element values in the given code equation, we get that equation equal to 0. So whenever f of element is equal to 0, so then we say that the given line is generator of given code. So this is the first model problem. Okay, so just in this video, I have defined the definition of code, and I have explained a few points regarding code. One is the fixed point, and second one is the arrow or the surface, and the third one is the individual straight line. Is called its generator. After that, a homogeneous equation in XYZ represents a code. The code equation generally represented by a homogeneous equation in XYZ. And after that, how we say that a generator, a line equation to be a generator of the given code. So that is what we have discussed in the two examples. Okay, thank you.